Hey guys, in this video we are going to talk about how to find and apply conditional probabilities using something called two-way frequency tables. So a two-way table is a table that records data that pertains to two different categories. So the table down here below shows the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find each probability. The first thing you should do when you see one of these tables is you should actually find the totals. So I'm going to find the total number of boys that were surveyed. So 18 plus 10, 28 boys were surveyed. Find the total number of girls surveyed. So 6 plus 16 is 22 girls that were surveyed. But you also want to find the horizontal totals. So those who prefer football, you have 18 plus 6, 24 of those surveyed prefer football. For hockey, 10 plus 16, 26 prefer hockey. And then just to double check your math, what you should do is you should total your totals. So 24 plus 26 is 50, and 28 plus 22 is 50. We surveyed 50 students, so that matches. That means we did our math right. So it's just kind of a nice way to check to make sure you're on the right track. So for our first example, we are being asked to find the probability that they prefer football given that they are a girl. This is going to be your denominator of your probability. So how many girls were surveyed? Well, there were 22 girls surveyed, so that's going to be my denominator. And then that they prefer football, well, how many girls prefer football? That's going to be your numerator. So I have 6 out of 22. And then if your fraction simplifies, make sure you simplify it. So this actually ends up being, let's see, 6 divided by 3 is 2, and then 22 divided by, whoops, I have a basic math error in my notes. Let's fix that real quick. I should be dividing this by 2 and dividing this by 2 to get 3 11ths. All right, perfect. Let's try the next one. So the probability that they are a boy given that they like hockey. So hockey, that's going to be our denominator. So how many people prefer hockey? Well, I have 26 that prefer hockey. So that's going to be my denominator. And then boys who prefer hockey is going to be my numerator. So boys that prefer hockey, I have 10 boys that prefer hockey. So I'm going to have 10 over 22. So again, that 10, that's the boys that prefer hockey. That's your numerator. And then all the people who prefer hockey, that's going to be your denominator. All right, perfect, guys. Let's go ahead and let's try another one. So this table here shows the results of a poll of 150 randomly selected students who were asked whether they take French or Spanish. So start off the same, find your totals. So the total people who take French, there's 82. Total who take Spanish, there's going to be 68 when I add all those together. Find your horizontal totals. So 6th graders, there were 42 6th graders surveyed, 19 plus 23. There were 37 7th graders totaled or surveyed. And then there were 71 8th graders surveyed. And then just double check, make sure if you add up all three of these numbers, that's 150. If you add up these two numbers, that's also 150. So the first question is asking you to find the probability that a 7th grader who takes French is randomly selected. Now, it does not have the vertical line. It does not say the word given that or such that, which means it's actually just a pure simple probability. So how many 7th graders take French? Well, there are 25 7th graders who take French out of 150 people surveyed. So we're going to have 25 out of 150, and then this fraction simplifies down to 1/6. So remember, probability is a word game. Can you understand what the question is asking you? It doesn't have the vertical line. It doesn't say given that. So it's just a pure, simple probability. All right, number 2, an 8th grader given that they take Spanish. All right, so this gets a little bit trickier. You have that vertical line given that. So remember, this then is going to be your denominator. So how many people take Spanish? Well, if I go to my table, there's a total of 68 people that take Spanish. So that's going to be my denominator. And then for my numerator of my probability, I need to figure out the 8th graders that take Spanish. Well, there are 33 8th graders that take Spanish. So I'm going to have 33, 68. And then this does not simplify. So the probability that you randomly select an 8th grader, given that they take Spanish, would be 33 out of 68. All right, let's try number 3. Find the probability that this randomly selected person takes French, given that they are a 6th grader. So again, denominator, numerator. Figure out how many people surveyed were 6th graders for your denominator. So how many people were 6th graders? There were 42 6th graders. Then figure out how many of those 6th graders take French. So how many 6th graders take French? There are 19 6th graders that take French, so we have 19 over 42. And then this does not simplify. So the probability that a randomly selected student takes French, given that they're a 6th grader, is 19 out of 42. All right, last one. For this one, I'm not going to mark up my table at all and just see if we can kind of figure it out. So the probability that they are a 7th grader, given that they take French. So how many people take French? Well, I have 82 people that take French. That's going to go on the bottom. How many of those are 7th graders? So how many 7th graders take French? 25. So the probability that the randomly selected person is a 7th grader that takes French is 25 out of 82. All right, awesome. Let's just try one more to make sure we really got this down. This table shows the results of a poll randomly selecting juniors and seniors asked if they had a driver's license. So go ahead, find your totals. So I have 84 juniors, 116 seniors. I have 125 yeses and 75 no's. And then just double check that those add up to the same number. So 125 plus 75 is 200. So is 84 plus 116. So we're good there. All right, so find the probability that a junior that does not have their driver's license. So again, pay attention to that language. You don't have the vertical bar. It does not say given that or such that, meaning you're looking at out of the total number of people surveyed. And then juniors that don't have driver's licenses. So I have 56 juniors that don't have a driver's license. And then this simplifies down. And we get out 7 out of 25. All right, perfect. Next one, probability that they do not have a driver's license given that they are a senior. So seniors, remember this is going to be your denominator. Seniors that don't have a driver's license is going to be your numerator. So I am asking a total of 116 seniors. So I'm going to have out of 116. Of the seniors surveyed, of those 116, 97 have one and 19 do not. This is asking for do not, so 19 out of 116. And that does not simplify because the 19 is prime. All right, last one, probability that they are junior given that they do have a driver's license. So this is my denominator. So how many people have a driver's license? There are 125 with a driver's license. And then juniors with a driver's license, there are only 28 juniors with a driver's license. And then this does not simplify. All right, perfect, guys. That concludes conditional probability using a two-way table. Check out the next video to look at how to use conditional probability with tree diagrams. Till next time.